Sri Sanjay Bhargav sir, Bajaj Center for Science, Mr. Biswas, Dr. Tiple, esteemed students, you are the epicenter of this activity and this very place. Also parents, I should say esteemed parents of these budding kids. I am very happy to see this premise in a place, Varda, where you have access to so many interesting things. The students are taking vibrations and resonance from these activities, and this is a wonderful learning time. I think you students are in wonderful era where you are catered with so many wonderful things around. I want to appreciate the management committee behind this for developing this wonderful opportunity for students of this town and around. Your management is embracing merit. Sri Bhargav Sahab told me that our principles are to cater to merit students. Whether you are able to afford the fees or not, that is not a question. So this is a wonderful environment wherein you are having your participation in the process of learning. I want to appreciate the vision behind this activity, and this kind of activity is definitely commercially not viable. But even then, if you are educating the budding kids, they are going to cater to the needs of the nation. And this is the broader view that the management behind can appreciate and invest upon. So it is irresistible for me to say that I want to appreciate the vision of Mr. Honorable Mr. Rahul Bajaj, who is behind all these activities. Today I am invited here to have interaction with students. As a physics professor, I am involved with young students, in the sense I am involved with the students of college. So today this is a wonderful opportunity for me to have interaction with kids. I want to ask a question. Are you comfortable with English, or sometime Marathi, Hindi is appreciated? Okay. Now I want to begin my interaction by telling you the course of development since the birth of this universe. As a student of this center, I believe that every student must be knowing that the most appreciated theory for creation of this world is Big Bang theory. This model was given by Friedman, and I think this was proposed in 1922, a way back. I mean, 102 years ago this was proposed. Now presently we are in 2024. So only 2024 years are there since the universe is created. This Big Bang occurred about 13.8 billion years ago. Approximately you can say 14 billion years ago, there was a dense matter and huge temperature. The theory is not capable of explaining why there came a fluctuation. But out of fluctuation, it exploded. That is called as Big Bang. And the matter was created out of energy. Only in 1905, Einstein could tell how the matter and energy are directly related. So energy is mass and mass is energy. The entire era of timeline can be split into two regions. The most accepted timeline is birth of Christ. We are following the calendar with that reference, and this 2024 is Anno Domini, that is after Domini. Before that, we call that era as before Christ. About 336 years. About 336 years before the birth of Christ, there was first elite group of people who used to gather on some property like you are gathering here, and they used to discuss things. And Aristotle was one of the part there who proposed a couple of laws of motion. I'm telling you the timeline, 336 years before Christ. So if you want to go back in time, 336 plus 2024 you have to make. Okay? So many years ago it was proposed. Those laws were not correct. However, in 17th century, Galileo and Newton came up with a modification. So, Principia Mathematica was the book published by Isaac Newton, wherein the experimental work of Galileo and its formulation in form of laws was proposed. About 2000 years, we were not having correct laws of motion. Therefore, these couple of laws are not taught in the school because they are redundant. A famous experiment was performed by Galileo, that was on Leaning Tower of Pisa. He dropped two objects of different masses, significantly different masses. And they observed that the two masses, which material object will reach to the ground first. Now I would like to ask a question. So one object say of 100 grams and another of say 1 gram, say a pigeon feather. Both are dropped simultaneously. Which will reach on the ground first?
100 grams.
Yes? Yes? Both will reach at same time. This is a correct answer. But practically what happens, if you drop a piece of paper along with a stone from first floor, you will observe that the stone will reach on the ground first. Paper will reach later on because it has buoyancy in air. Air resistance will play an important role. But if you minimize air resistance, in that situation, both objects will reach on the ground at the same time. Recently, NASA has performed one wonderful experiment wherein they dropped the pigeon feather along with a 60 kg bob of iron, and this they did in an evacuated chamber, which is about the height of 4 floors you can consider. On YouTube you can search for this video, and both the objects reach on the ground at the same point of time. High-speed cameras are used, and from your mobile you can look at the experimental findings. So you are learning something in the classroom, you are doing experimentation is the next stage, and analysis is the third stage. So after about 2000 years after Aristotle, this experiment was performed and Aristotle's laws were scrapped and they are not taught in the school now. Now we are starting our schooling with Newton's laws of motion and the related mechanics. We call that as classical mechanics or Newtonian mechanics. Then Albert Einstein came in 1905 with a new theory that is called as spatial theory of relativity. This was the miraculous year 1905 when he turned the entire knowledge, he turned the entire known physics of that time. It was thought that everything is established very well and now only you have to convert the known things in the form of technology and devices. But in 1905, Einstein came up with new theory which was not accepted easily. He went to an ordinary journal to publish his paper and then that journal became a big player. So he considered that space coordinates, you must be acquainted with the number system and x, y, z three-dimensional coordinates. So some meters along x direction, some meters along y direction and some meters along z direction will take you anywhere in the space. So Einstein added that this is not sufficient description, you should have time along with that. So x, y, z, t, he proposed four-dimensional space-time continuum. It is very difficult to imagine four dimensions. If somebody is teaching on blackboard, the blackboard is two-dimensional and one is expected to deliver something in four dimensions, that becomes difficult. So for simplicity, you can consider x as one space dimension and time as another dimension. So space and time should be considered together. But the problem is that space has dimension that you can consider in meters, you can measure in meters, and time is measured in seconds. So can you add 3 buffaloes with 2 cows? No, they are two different entities. So you cannot directly process such numbers. So a wonderful idea was proposed by Albert Einstein. Instead of considering time, he called that quantity as velocity of light into time. Velocity of light we denote by small c. It will be meter per second, right? So c into t you have to consider, meter per second into second. So second you can cancel, and ct has dimension of space. So he has used this wonderful idea to develop a continuum of space and time. So to talk about relativity, we are teaching this subject to BSc final year students when they are well acquainted with Newtonian mechanics. So you all being school students, I think from 6th standard you are here. I want to touch the periphery of the subject and give you a glimpse of what was the fundamental idea of Isaac Newton in combining space and time as a complete continuum. So out of this theory, he came with an equation E equal to mc square. So energy is mass and mass is energy. But they cannot be converted immediately like you feel like burning a piece of wood and creating heat. So it cannot be so easily converted. There needs some conditions. We shall try to understand this in form of a timeline. So after 1905, Einstein came with a new theory in 1915 that is known as general theory of relativity. This is the most complicated theory ever produced, and in contrast, most successful theory ever produced. This talks about the giant objects and longer distances. The basic equation Einstein developed, is a combination of 16 equations. Capital G, suffix mu nu, mu and nu, they are indices you can consider. G suffix mu nu equal to kappa times, kind of constant, Greek constant, into T mu nu. So he was talking there in terms of the curvature of space and time, which is created by the presence of mass. His theory was tested very widely by Eddington and others, and it proved to be correct in all the attempts of check. So Einstein was recognized as the greatest scientist, and I think the fanfare he received, no other scientist has enjoyed that kind of fanfare. In I think 1922, one landmark experiment was done that is known as Rutherford's alpha scattering experiment. Now you imagine that you have a hammer and you throw that hammer on a paper. Like we have a kind of thin paper, butter paper, which is fixed on a window, and you throw a hammer on that. What will happen? It will tear off the paper and will march ahead almost without any change in its momentum. Right? Am I right? But think about that hammer is bounced back. What will you feel? This is a very amazing kind of experience that one can ever think about. He experienced that when alpha particles were bombarded on thin sheet of gold, some alpha particles were bounced back, and from that we could know that there is something very dense inside the atom, and it was called nucleus. Later on, nuclear physics, an entire new branch was developed. Then in around 1929, we could understand fission and fusion reactions. After knowing that, we could understand the source of energy that comes from sun. So how long it will burn, how long it will be capable of giving us the radiations, which are very much required for sustainability of life on this planet. I think it is 5 billion years it is going to work for us. Later on, it will be converted into white dwarf. The Einstein's theory gave us a very peculiar speciality about velocity of light. Anything which is massless can travel in space with the velocity of light, which is 3 lakh kilometers per second. In general theory of relativity, when we talk about velocity of light, we consider c equal to 1. We prefer such a system where C is 1 unit, but actually in reference to our MKS system, we call that as 3 lakh kilometers per second. Nothing can travel in space faster than speed of light, and any material particle cannot travel even with the speed of light because its mass will go on increasing. That is the outcome of Einstein's special theory of relativity. I think in 11th standard, when you will go, you will be able to write an equation for escape velocity. And I would like to tell you that if you want to throw something out of the gravitational field of this planet Earth, you have to throw it with velocity 11.9 kilometer per second. ऑलमोस्ट 12 किलोमीटर पर सेकंड से आप किसी चीज को बाहर फेंकेंगे तो अर्थ की ग्रेविटेशनल फील्ड से वो बाहर चला जाएगा. This is called escape velocity. Minimum this velocity is required. If you have more than that, it is fine. If it is less, it will fall back. Now this escape velocity on Sun is 617 kilometer per second. So it is yet more difficult to escape from Sun. Again, the temperature is another issue. On the surface it is 5000 degrees centigrade and in the core it is million degrees centigrade. So this escape velocity is directly proportional to under root of mass. So you can roughly consider as mass increases, escape velocity increases. So you think of heavier and heavier and heavier objects, the escape velocity will go on increasing. And think about a situation when the escape velocity is equal to velocity of light or even more than the escape velocity of light. Think of a demon, you go near him and he will not let you go off. So that is called black hole. When the object is massive and the escape velocity is greater than or equal to velocity of light, nothing, not even light, can escape from such objects. Those are called black holes. We could understand the meaning of black hole and existence of black hole theoretically just after knowing absoluteness of velocity of light, which we could know from Einstein's special theory of relativity. In 1929-28, we could understand fission and fusion based on Einstein's equation E equal to mc square. And atom bomb was created. I hope you must have seen that movie Oppenheimer. So all the scientists of physics, they are part and parcel of that movie, which is a well articulated movie that every child who has quest for knowledge should see. Now, instead of making a continuous monologue, I would like to have a dialogue with you, children. So I would like you to raise some questions, and I'm also wondering whether I'll be able to answer your questions or not, because the students are very inquisitive. Yes, please. You tell your name of your school, and then your question.
So good evening, sir. Myself Shauresh Lote from Standard STEM School. My school's name is St. Anthony National School. And my question is, as you said, there are 3 stages of learning, right? We learn, then we experiment, then we analyze. Analysis is, I have seen like typically, analysis are mainly done on papers and on whiteboards and blackboards, right? And with numbers. But how can we integrate this analysis in our daily life, right? And make it much more interesting in that sense, that a common person who is living with us, who doesn't have that knowledge, like that required knowledge with us, but still can understand the basics. How can we convey that knowledge in such a way?
I want to appreciate you, sir. He catched the three words, three stages of learning. That learning laws in a classroom or through book, then doing experimentation, and then making analysis. So making analysis is basic integral part. A farmer is going in the farm, planning, sowing, cultivating. Mother is going in the kitchen, cooking for you and matching a time with you. This is analytic part that one has already chalked out. When you are getting up to go to school in the morning after vacations, the first day you miserably fell because, because you are not aware of how much time you should spend on which activity. So this analytical part is already into our mind, and we are using that analytical power to make our things smooth and effective. And when it comes to scientific analysis, then it is very meaningful in the sense all laws, if you try to understand, they are well articulated based on the observations. Now, if you go with Newton's second law, force is nothing but the rate of change of momentum. And if you go in the laboratory and try to establish that, you are measuring the rate of change of momentum. You are measuring momentum with time and then finding rate of change of momentum. And that is equivalent to the dragging force you apply with a pulley. So that goes hand in hand. Like body language. Alan Pease has written a wonderful book, Body Language, where the body language is in coordination with the thoughts, and the thoughts coordinate your body language. So analysis is the integral part of the happening things, and that is very obvious in every day-to-day exam. Wonderful question.
In extension to this, once I heard, I think in a book or somewhere, that learning first starts with realization. Once you know something, then you realize it, then you understand it. So that's the path of learning,
Yes.
right? And when you read books, we know something, then we go experiment, we realize it, and then we understand it, right? So it's a hideous in the sense the knowledge is not given or the understanding is not given directly, right? But when we start to understanding, there's a certain fascination that then triggers that curiosity and keeps you going, right? So that was my intention. That was something I want to ask.
Yes. Actually, we learn by experiences. And many times what happens, whatever experience your mother has, she tells you, don't do this. But I feel that you should explore. You should explore to understand. But you should not damage yourself in those experiences. So, exploration and doing by self and understanding is an integral part of learning, and one has to go through that. In the laboratory, your teachers are already knowing what will be the end result of the experiment, but they are giving you a feeling of understanding how the things are going. So this is the integral part of life.
Thank you, sir. Thanks a lot.
आमचे विद्यार्थी असतील ते सुद्धा मराठीमधनं प्रश्न विचारू शकतात. मराठीमध्ये सायंटिफिक टर्म्स भार्गव साहेब मोठ्या तुम्ही मराठी मीडियममधून शिकलात का? ॲक्सेलरेशनला त्वरण म्हणतात, मोमेंटमला संवेग म्हणतात. I think kids, your mothers must have learned from Marathi school, because this trend of English school has come recently. Yes, please.
Sir,
So my name is Vijay Pauro. I study in class 10 in St. Anthony National School. So you said how Einstein gave the general theory of relativity and how it was the most evolutionary thing ever in physics. But the thing is, Einstein got his Nobel Prize in some in some field of quantum physics. So why didn't he get a prize in theory of relativity?
This is a very technical thing. I feel that Einstein should have given at least 4 Nobel Prizes for his special theory of relativity, for his general theory of relativity, for Bose-Einstein statistics, and the thing for which he got Nobel Prize is photoelectric effect. The concept is wonderful, the equation is simple. My fellow friends, Dr. Tiple and Dr. Erpude, will also agree with me. The photoelectric equation is a very simple equation that comes from the basics of background of quantum mechanics, and we feel delighted whenever we are teaching in the classroom that such a simple equation, a wonderful idea, but behind that he was awarded Nobel Prize. The names are recommended, the process is political. The way we see politics in India, more or less in similar fashion, that politics is there. I believe that Einstein's work is marvelous in the sense that he should have at least 4 Nobel Prizes. That is what my feeling is. And getting recognition for something is one part. However, there are many scientists who have contributed to the field of science in great ways, but that is not recognized. That is also a story. Recently, I was reading about action. Now, school boys will not be able to understand, my fellow physics professors will be able to understand the Hamiltonian's action principle. So that basically started with Mapotis, who was in 16th century. But when he proposed that, he was not appreciated. Forget about that. He was ridiculed. You can go to the Google and search out the action by Mapotis.
Yeah, then
So,
after his death, Euler continued it,
Are
and then
wonderful.
Euler and that one more Lagrange.
Lagrange contributed to that. So I am mesmerized with this boy. Tell your name again.
Rigved Thavde.
Rigved, claps for you. So Mapotis proposed that action is mass into velocity into displacement. So the action is more if something is moving faster. Action is more if something is heavier. And action is more if you are taking it to longer distance. So this idea was ridiculed. But after his death, people recognized the Mapotis' contribution. And now, in the modern way, we learn that, we teach that, we understand that in form of Hamiltonian principle of least action. So it is like that. So certain things are political. We should go on doing what we like, and the result is left to the nature to bounce back.
So one more thing that I want to ask is there any way we can relate quantum theory with the theory of relativity?
सर ये बच्चे तो हमारे पोस्ट ग्रेजुएट स्टूडेंट्स के भी आगे हैं. Now see, I think in 2012 I gave a lecture in Dharampet Science College on conflict of principles. So two independent established rules, one you can say Newton's law, which is very well tested and settled, and another you can say Boltzmann's entropy relation. The entropy is ever increasing. So one is bidirectional, multidirectional, another is unidirectional. Both are correct. But when we try to combine these two, we miserably fail. What is happening? It leads to conflict and confusion. But out of that, a great knowledge comes जो इंडिपेंडेंट दो लॉ से नहीं मिला, उससे ज़्यादा ये कॉन्फ्लिक्ट से मिला. ऐसी ही केस है. द जनरल थियरी ऑफ रिलेटिविटी इज अबाउट सेलेस्टियल ऑब्जेक्ट्स like our planet, solar system, Sagittarius A, the mega black hole, and all. And quantum mechanics is for those things which are so small in size that you cannot see them even through microscope. So when we combine these two things together, that leads to something very fascinating. Professor Leonard Susskind works in Stanford University. When I had been to US, I tried to get his appointment to have interaction with him. He is the one who worked on string theory, who is one of the fathers of string theory. You can find him on the website of Stanford University and YouTube. You can find his lectures. So he is a person who talks on the combining effect of the general theory of relativity which is for mega objects and quantum. So they are talking about gravitons instead of gravitational force. They are talking about the gravitational field in terms of gravitons. So you baby grow up and take physics as your career. I feel so.
Thank you, sir.
अभी मुझे थोड़ा डर भी लगने लगा है. 6th standard boy also should come up. This is a wonderful gathering. This is a homely environment, and there's nothing formal. You can pick up mic and open a dialogue. This is a wonderful opportunity to express and listen to. I am also very happy to be with you all. जिसने बीटेक किया था आईआईटी मुंबई से, she was damn interested in physics. She used to be topper in all fields. Swimming में number 1, badminton में number 1. So she later on joined physics. So physics is a discipline of great interest. We feel my fellow friends will agree with me. And nowadays students are little more, I mean younger students who are coming to college, they are not very keen in preferring physics. But I am very happy that the school boys are very enthusiastic. So any question? Yes.
Okay, so my name is Himanshu Shivsagar. I am studying in Standard 9 from Agadami High School, Pipri, Varga. My question is that when I am watching a video about Big Bang Theory, I came to know that matter doesn't have mass from the starting, but because of the particles, which is known as Higgs bosons, that's why the matter has got mass. But how would the contemporary scientists came to know about this?
Actually, yes, please sit down. Actually, as I said, it is 13.8 billion years ago this event occurred, and now we are posing questions. We came to know about the appropriate theories. Newton gave us his theory, Newtonian theory, in 1667 around. Einstein gave us a theory in 1905 and 1915, special theory and general theory. So we tried to gather the information about how this universe has been created. In Friedman's model, which is the most successful model that advocates Big Bang theory, tells us that there was energy concentrated at a point. It was, point means dimensionless, no length, breadth, height, and enormous amount of energy was gathered at that point. There was no space and there was no time. So where from it came, the Friedman model is not able to talk about that. But we are not having any option other than Friedman's model, which is capable of explaining things in the most appropriate way. Then there came a fluctuation, has no explanation wherefrom such a quantum fluctuation might have occurred there. And after that fluctuation, it exploded and time started and space was created. So this started expanding. In I think 1922, Hubble gave his law on basis of his observations. So Hubble's law, I want to tell you the analytical approach. So everything is receding away from the center. Everything is receding away from each other. So if I go towards Bhargav sir, I am going away from this part. But the concept of expansion is that you consider a balloon with colored dots, and when you pump air into the balloon, every colored dots recedes away from each other. So this expansion we could know in 1922 after Hubble's law. Hubble's telescope was there to make these observations, and later on it was converted into law. Till then, we were not knowing anything about it. In 1922, Friedman was able to develop a model, Richardson-Friedman model, which talks about this Big Bang theory. So this is the time when we started, analyzing what must have happened. And Higgs bosons, which were theoretically proposed, were proved to be existing recently, and those were in the early part during this expansion. So how much light must have traveled? The speed of light, as I said, it is 3 lakh kilometer per second. This number is to be multiplied by 13.8 billion years. So 13.8 billion you convert in power 9 years, 365 days you have to multiply by 365, each day of 24 hours, each hour of 60 minutes, and each minute of 60 seconds. So light must have traveled this much distance, and that is the expansion boundary of the universe. To those who are very keen in learning, I would propose that you should take up a Coursera course. Coursera. Coursera is a online learning platform, and there you pick up a course from Big Bang to dark energy. I have done this course during Corona quarantine period. Hitoshi Murayama is the course coordinator, and he is the wonderful physics teacher I ever met, I ever learned. So you just keep in your mind, whenever you are free from your school responsibilities, you should enroll on Coursera with your Gmail ID, and you can start learning. If you want certificate, you will have to pay 2,200 rupees to get the certificate. Otherwise, it's free. You can learn, you can appear for their online quiz. Their passing percentage is 80%. Minimum passing percentage is 80. If you don't get 80%, you reappear for the examination and you will be surprised with new questions. So you can go on doing that until you get 80%, and then you are said qualified. If you want certificate, you have to pay, otherwise you can complete your process of learning. Okay? Sir, should I stop? Thank you.